This conference will now be recorded.
All right, this is a Math 211 video. I'm going to be going through the previous knowledge from algebra and trig. That was one of our set of notes that we had the other day. We did not get through all of that. There was one example in particular that I wanted to make sure that we did, and then the ones that were at the very end about the conic sections, I actually cut those out because we will get to, I'll just put them back in the notes when we actually need that. So if we look at, I believe it was example number 6. Yes, this is the one we did not get to in class. So it says graph and state the solution in interval notation. So I'm going to go ahead and get my ink. Sometimes you have to fiddle with this. There we go. All right, so the first thing I would do is I would get this so that it is all of the values and constants are on one side together. So let's take this and let's subtract over that 3. So 2x squared plus x minus 3 is greater than or equal to 0. Now, if we want to consider this as a graphing problem instead of an inequality that is just a polynomial and do a sign chart, so just trying to do this by the directions, I would try to graph the function 2x squared plus x minus 3, which is a parabola. And I would also graph when is g of x equal to 0. That's kind of the other side. And we want to look for where do they intersect, because then we can talk about when is it above or when is it below, which would be in reference to greater than or equal to, and less than if we needed less than. So the first thing you want to do when you're graphing a parabola is you want to get the vertex. So remember, there's a formula for vertex. This is something you would have learned in a Math 136 class. You would do negative b over 2a, and then you plug that into your function to get the y value. Now, remember, negative b over 2a is in reference to the quadratic formula, but it's also, remember, we label all of our trinomials that are quadratic a, b, and c for their coefficients. So this would be, the x term of that vertex would be negative 1, because that's the b value, over 2 times a. So I'm getting a value of negative 1/4 from the x value of my vertex. I would then plug that into my function to find the y value. So 2 times negative 1/4 squared plus negative 1/4 minus 3. That is 2 times 1 over 16 because it got squared, minus 1/4 minus 3. That's going to be 1/8. I'm going to go ahead and get a common denominator of 8, so that would be 2/8. And if this is 3 over 1, that would make that minus 24 over 8. This would be negative 26 plus 1, so that's negative 25 over 8. That's not as easy for us to graph, especially if we don't have a calculator to help us turn it into a decimal. So 8 goes into 25 3 times evenly, because that would be 24, with 1 left over. So it's negative 3 and 1/8 if we want to make it a rough estimate of where we're going to graph that. That helps. So that's our vertex. The other thing I would find is your x-intercepts, and you find that by setting the function equal to 0 and seeing if you can solve that either by factoring or quadratic formula. Since this is the trinomials with a non-1 in front, you would do 2 times negative 3, which is negative 6. 1 and 6, 2 and 3. Looks like if we use a negative 2 and a positive 3, that will factor. So this would be 2x squared minus 2x plus 3x minus 3. If we factor by grouping, this would be 2x, and that would be x minus 1, plus 3x minus 1. So we do get an x minus 1 and a 2x plus 3. Now that would solve to an x equals 1 and an x equals negative 3/2. So my x-intercepts, because that's when we set it equal to 0, would be 1, 0, and negative 3/2, 0. And that should really be all that we need to graph this problem. So we're going to rough sketch it. Again, I'm not being very particular, just trying to make things as evenly spaced as I can. 1, 0, so I'm going to change my color here. This is going to be one of my x-intercepts, so that's right there. Negative 3/2 is negative 1.5, so that's another x-intercept. And the vertex was negative 0.25 and then down negative 3 1/8. And so this parabola would go like this. But the question is, what is g of x? Because that was, remember, the other function. So this is f of x. That was the left side of our inequality. And g of x is going to be y equals 0, essentially. So if you think about it, that's g of x. So where they're equal to each other are the x-intercepts, because that's where those two lines intersect. So we know that -1 and negative 3/2 and +1 are part of this solution because it did say equal to. Above the purple line is where the function is going to be greater than the 0 value. And below the purple line is where the function is going to be, the f of x is going to be less than the g of x. For us, though, we're wanting to write this in interval notation, which means we're referencing it on the x values on the x-axis, essentially. So from here to here, which is -∞ to -3/2, all of the graph here is above, which you can't really read that, so I'll write that in a different word. Color, we'll do that in the black. So these are all above from this region right here. That is also true over here. Everything that is in f of x here is above. So this part right here is where we are below. So this is when we're less than 0, and these two are both when we are greater than 0 for our function value. Because remember, we're comparing this red parabola to this purple line. So since we asked for greater than or equal to, we're actually going to use the two shaded in yellow regions, and we're going to use a bracket to include those endpoints. So the answer is -∞ to -3/2 with a bracket, unioned with bracket 1 to infinity. And since we cut off the conic sections, because I said that one was really not going to, like I said, I'll just add it in when we need it. That ends the review of previous knowledge from 211.